Hello, my name is Lulu Chen. This is my presentation for Big Data for Health class project. The topic I picked is septic shock prediction with Mimic 3. So why I picked this topic? The hospitalization rate for sepsis has doubled from 2000 to 2008, according to CDC. The mortality rate, though, decreased over time, but still averaged around 15% to 29% in 2009. And the hospital cost has tripled over time. There are multiple initiatives in place to raise public awareness of sepsis. So first, the definition of sepsis. There are different definitions of sepsis being proposed over time. The first definition was ACIRS, proposed in 1991's consensus conference. It's the lightest form of sepsis. In general, it's being criticized that it's capturing too many false positives. So in 2001, they came up with a new definition of sepsis, which is ACIRS with infection. In 2001, 2016, they have also proposed a more severe form of sepsis, which is sepsis and organ dysfunction. The criteria Henry et al. Used in his study is coming from 2012 Surviving Sepsis Campaign guidelines. It's very similar to the severe sepsis definition in consensus conference, but also overlaps with septic shock, which is an even more severe form of severe sepsis. Nonetheless, they use very similar variable to determine whether a patient has severe sepsis or septic shock. In the following study, however, I'm not going to use the clinical measurement as a criteria to determine whether a patient has sepsis, severe sepsis or not. I'm going to use ICD-9 code, partly because I believe if we use the same variables that's used in training the model and deriving the dependent variable is going to bias the accuracy, because basically you're using the same variables in both dependent and independent variables. The other reason is because with newer data available, we have more clear definition of sepsis over the time. So even though in general in history, ICD-9 code has been criticized to identify too many false positives. However, because more clear definition, I hope this has been remedied over time. The variable I use in my model training is very similar. Basically, everything that we just discussed from the sepsis definition in the literature mostly overlap with Henry et al.'s study. The prediction window, I use everything 15 hours prior to the death time or max discharge time of hospital admission if the patient is still alive, to 30 days. The model I use is logistic regression first, because it gives us a sense of how the model works, how the algorithm make prediction, which would be helpful in a case that the definition is controversial in general. There are not too many clinical studies to prove that this definition works. Also the speed, even though in our case we only have 1.2 million rows, so it's not big enough to cause significant impact in the speed, but in practice it's going to be much bigger data set, and this provides us really fast training and prediction time. So how is the model? The model is in general good. The best area on the curve is 77%. True positive rate is very good on the test say 97%. False positive rate is on the lower range 42%. So it's going to identify all those with propensity to have severe sepsis or a septic shock, but it could also over-identify too many false positive cases. Time obviously has the most important impact in the prediction. The more closer to the last minute, the 15-hour cutoff, the better the prediction works. All other variables, as you can see here, has some kind of impact on the prediction. It's very similar to Henriette's study. So this is my presentation. Thank you.